Okay, this is lesson 6 from Unit 3 of Algebra 2. We are converting from standard form to vertex form by completing the square. In our last lesson, we learned to recognize vertex form of a quadratic. And usually when we're in vertex forms, that's easily identifiable because we have parentheses around like our x term and another number, and all that's being squared, and then there's a lot of times a number that's being added or subtracted outside the parentheses. We really like vertex form because when we are in vertex form as opposed to standard form, we can identify the vertex of the parabola without having to do any additional math or algebra. So if you're looking at all of these examples that we have here, like x squared plus 8x plus 16, okay, here a squared plus 2a plus 1, m squared minus 18 plus 81, and p squared minus 10p plus 25. All of these quadratics, because x is squared again, are in standard form. Okay, they're all lined out in a row. You know, like we have our x squared and then our x value and then our constant. Okay, that's in this, what I'm highlighting up here, 8x squared plus bx plus c form, which is standard form. And that's not bad. It has a lot of uses. It let us see what like the a value, the b value, and the c values are, but it doesn't tell us what the vertex is just by being able to look at it. So we are going to be able to show how we can take an equation in standard form and convert it into vertex form. And to do that, we're going to start off by talking about what a perfect square trinomial is. Okay, so a trinomial is when we have three terms. We have quadratic trinomials where we have x squared as our highest exponent and then three terms. So a trinomial in the form of ax squared plus bx plus c, where, let me get my pen, we say we have half the b value and we can square that is equal to our a value times our c value. Okay, sorry, this is a b. And again, you have to remember, a means a number in front of x squared, b means a number in front of x, and c is our constant. Okay, so we're saying we have a perfect square trinomial when we can take half the b value, square it, and that's the same thing as our a, or coefficient of x squared, times a constant. So let's do a few of these examples to see what that means. It says factor the following trinomial. So starting, I'm going to label this number 1, we have x squared plus 8x plus 16. So some of you remember this. I say 1, 2, 3 factor tree. What multiplies to 16 and adds to 8? Well, that would be positive 4 and positive 4. Okay, so because we end up with an x plus 4 times an x plus 4, notice I have two of the same factors. That can be written as x plus 4, all in parentheses, being squared. Squared always means multiplying by what's inside those parentheses by its own self. So if you're looking at this, this x plus 4 squared is in vertex form. The vertex of this would be negative 4 comma 0. Okay, so it just made it a little bit easier to identify that vertex, which you always have to find when you're graphing. So we'll continue on doing this with each of these examples. I'm going to do the one underneath, a squared plus 2a plus 1. What multiplies to 1 and adds to 2? Well, that would be 1 times 1, 2 positive 1s. Multiply to 1, but add across to 2. So we would have a plus 1 times a plus 1, which is really a plus 1, all in parentheses, squared. Again, so that's why it's a perfect square trinomial, because the two factors are the same. We can write it as a perfect square. And again, what is the vertex of this? We could say the vertex would be opposite of what's inside the parentheses, and 0 for y, because we're adding nothing outside of it. Okay, our third example, we have m squared minus 18m plus 81. So the two numbers, again, because we're dealing with perfect square trinomials, they are going to be the same number, the same two factors. But what multiplies to positive 81 but adds to negative 18? That would be negative 9 and negative 9. Okay, so we have two of the same factors again, m minus 9. m minus 9 is how it would look factored. But we could rewrite it because it's a perfect square here, two of the same terms being multiplied. So we have m minus 9 all being squared. Now what does that make the vertex for this one? Okay, because we have a value inside the parentheses, it would have made it like 9 for x, positive 9, and 0 for y. Okay, one last example. Okay, well, we'll label this number 4. We have p squared minus 10p plus 25. So 1, 2, 3, factor tree. Multiplying to positive 25 and adding to negative 10. That would be negative 5 times negative 5. So we could write it as p minus 5 times p minus 5. But we have 2 of the same factor, so we can write it as a perfect square. P minus 5 squared. And if we were dealing with x and y's here instead of like these different variables, obviously that's a p. But we could technically, like say, if we were doing vertex form, that this would make the vertex positive 5 and 0. And so we like things to be in vertex form to help us find the vertex just faster, quicker. So as we go all throughout this lesson, we are going to be given a problem in standard form. Now, not every example we are going to have is going to already be a perfect square trinomial. It doesn't work that way, right? It would be nice, but it doesn't happen. So we're going to have all these examples where we're going to have to make changes to them, and we're going to go through the same process every time to find a portion that we can make a perfect square trinomial so that we can rewrite this problem in vertex form. Okay, so looking here at the top, it says if the standard form equation is a perfect square trinomial, like we're going to have in example 1, and very similar to what we did in those first 4 examples, we simply have to factor to convert to vertex form. There's no tricks to it, basically. If it's not a perfect square trinomial, meaning it's not the same 2 numbers that multiply to the last value and add to the middle, then we have to use a process called completing the square to write the equation in vertex form. And then I really like this over here to the side. It shows standard form. What we're talking about, standard form is when we have our x squared, then our x, and then our c kind of in a row. And then vertex form shows like how it looks in the parentheses. We have our a value, and then x minus h in parentheses squared plus k. So we're kind of changing it to where we're using parentheses and the squared's outside of that. And that's how we identify the vertex. So that's what we're doing here. So we have all these steps. Starting with step 1 here, says first make a grouping out of our x squared and our x term. We're going to put them together in parentheses. We're kind of going to be clicky here, and we're going to kick the c term on the outside of the parentheses. And then it says on step 2, if our a value does not equal 1, okay, so if it's 2 larger or even if it's a fraction, we have to factor it out so that the a value is outside the parentheses and we're just left with x squared plus bx inside. C, or 3, not C, I don't know, I said that. Complete the square by taking half the b value and squaring it. This is our new c. We are going to add this value to the x squared plus bx inside the parentheses, and now we have a perfect square trinomial that we'll see. It's inside parentheses, and it's going to be super easy to factor. Now that new c that we've added inside the parentheses, we're going to subtract it, and if we did factor an a value out, we subtract the a times c value from the end of the equation. And I'm going to show that with some boxes here in a little bit. So that was step 4. So it gets added inside the parentheses, subtracted outside the parentheses. And step 5, we're going to factor the trinomial and simplify the end of the equation, and then it will be in vertex form. And then we will say what that vertex is. So that's what we're going to do on these next examples. Okay, looking at number 1, we have f of x equals x squared plus 4x plus 4. And again, this is standard form. We're going to convert it to vertex form. And even though we were already told that number 1 is a perfect square trinomial, let's pretend we didn't recognize that, and we can still apply the completing the square process to this problem. So we're going to look, and don't forget that, remember, a is a number in front of x squared, the b value is a number in front of just the regular x, and c is the constant, just the regular number. So working through our steps, they're down here. Step 1 says make a group out of ax squared plus bx. So we're going to put x squared plus 4x in parentheses together, and we're basically kicking out that positive 4 outside the parentheses. Really got kicked out of the cool kid group. Okay, it said if we had a value in front of x squared other than 1, we would need to factor it out. But in front of x squared, we don't have a coefficient other than 1, so we're fine, and we kind of get to skip step 2 because it doesn't apply here. Now we're going to do what's called completing the square. So we're on step 3. It says take half the b value. Well, my b value, okay, is 4. 4 is the b value. So we're going to take 4 and we're going to take half of it, which means divide it by 2. So that equals 2. And then we're going to square that number. So 2 squared is 4. Because again, I just take half of b and square it. That's what we did. This is the new c value, okay? 4 is the new c value. Cool. It says add this to the x squared plus bx. So moving down from here, I'm going to show it like this. We're going to have x squared plus 4x. Something always has to be added inside the parentheses. And notice I had a plus 4. That was this value. And we subtract that same value on the outside of the parentheses. Okay, so what's that number that goes in the box? That's our c value, 4. So we're adding 4 inside the box, and we subtract it. If there was a number out here, we would multiply that 4 by that a value first, but we don't have that yet. We'll deal with that later. So we're subtracting it outside. Okay, so what do we do next? It says that we need to, on step 5, factor that trinomial now. Now it's going to be really easy because factoring what's inside, we are asking what multiplies to 4 and adds to 4. Well, that's always going to be what half of b was. It's always going to be that number, 2 times 2 equals 4. 2 plus 2 is 4. So again, we could write this as x plus 2 times x plus 2, but instead I'm going to write it as x plus 2 all being squared. Okay, so we've simplified the factoring part here, and now we simplify what came after the parentheses. We have positive 4 and negative 4, which equals 0. So I don't even have to write anything else. Our equation now for vertex form is just f of x equals x plus 2 in parentheses squared. And then we could even answer here, what is the vertex of this? Okay, remember vertex form, we've had this lesson. The vertex, our ordered pair, we take the opposite of what's with the x in parentheses, so we make it negative 2, and then the y value of the vertex is what's being added or subtracted after that, and that was 0. So our vertex of this problem is negative 2, 0. Okay, so we're really just going to work through those same steps on every problem. These next examples will not be perfect square trinomials, so you'll notice that the y value from our vertex won't be 0 like it has been in these past examples. But again, work through these steps. Let me erase these down here to kind of let us start over. And notice that number 2, we say f of x equals x squared minus 8x plus 18. So step 1, group your x squared and your x term together. So I'm going to rewrite this as x squared minus 8x, and then we have plus 18 on the outside. Okay, kicked out the constant. Must have done something bad. Then we're going to take our b value. So the b value again is the x term. It's negative 8. So we're going to take negative 8, divide it by 2. That equals negative 4. And then we always put parentheses around it to square it. So after we square it, before we square it, it could be negative, but after we square it, it will always be positive because this means negative 4 times negative 4. So now I'm going to kind of rebuild this. I'm going to have my x squared minus 8x, and I'm going to leave space, and I have this plus 18. This is what I had from above right here. And I'm going to say we're going to have plus a box inside the parentheses, but minus this box outside the parentheses. What do we put in the box? We put our new c value. Okay, that's the new c, 16, the half of b squared. So we're going to put 16 here and here. Notice it's basically the same number, but we're adding it inside, subtracting it outside. That's the rules. That's why I'm doing it. So how do we factor this? X squared minus 8x plus 16, what multiplies to 16 but adds to negative 8? Here's the awesome thing. It's always going to be what half the b value is, that number before we squared it, negative 4. So you have a clue for your factoring. I love clues. Okay, so we have now x minus 4 times x minus 4, which we will write as x minus 4 squared. And what do we get when we simplify the outside? Positive 18 minus 16 is positive 2. So 18 minus 16, positive 2. Okay, we're going to throw an f of x in front of all this so that it is a function. It's an equation. Okay, that's in vertex form now. It's the same, going to be the same parabola as x squared minus 8x plus 18, but written in a different way. But what's our vertex? Our vertex will be at positive 4, the opposite of what was with the x, and then the y value always stays the same, positive 2. That's our vertex. Makes it so much easier to graph when we are in vertex form. Okay, number 3, our example is f of x equals negative x squared plus 6x minus 5. Okay, my steps don't change. First thing we're going to do is make a grouping out of our first two terms. So we're going to put in parentheses negative x squared plus 6x, close it, and we kicked out the constant. Minus 5's on the outside. Poor guy. Now, before we skip step 2, but this time we have to apply it. It says if a is not equal to positive 1, we have to factor it out. So our a value here is negative 1. We don't want a negative in front of our x squared, so we can pull it out. Okay, that means we're dividing each of these terms basically by negative. Negative x squared divided by that negative becomes positive x squared. Positive 6x divided by negative 1 becomes negative 6x. Okay, now think about it. If we distributed this negative sign back in, we would get back to the original problem. So I do know we factored correctly. I'm going to bring down that minus 5. No changes there. Okay, so that makes our b value negative 6. So now we're ready to take the b value. So that's b. Negative 6, we're going to divide it by 2, which is negative 3. And then we put parentheses around it and square it. Negative 3 times negative 3 is positive 9. So again, we do two things with that positive 9. We're going to rebuild the problem. So I'm having x squared minus 6x, and I'm going to say plus an empty box. I'm going to have minus 5 from above, and then minus my same box. And again, I'm using this box to show that like basically the same number goes in both places with one little difference. Now notice I had this minus sign right here. I still need to use it, okay? We need to put it on the outside. We can't lose it. I almost lost it. Don't do that. So what number goes in the box? I'm going to put 9 inside. Okay, no changes. It's the exact C value. But to put the number in the outside box, it's this C and that's A. We have to do negative 1 times 9, which is negative 9. Okay, this is going to be A times C if we changed like what the A value is, if we pulled something else out. Okay, so that's what it meant when it said A times C. I put negative 9 there. So now we're going back and we are factoring what is inside the parentheses. And again, it should be a perfect square trinomial at this point. I'm thinking what multiplies a positive 9 and adds to negative 6. Again, we have a clue. It's always going to be that half of b value before we squared it, negative 3 times negative 3. So we rewrite this as negative on the outside. Again, I'm not losing that negative. And then we have x minus 3 in parentheses. That's all being squared. And then what's going outside the parentheses is simplifying my outside number and what was in the box. I have negative 5 minus negative 9, which is negative 5 plus 9, which is positive 4. So I just going to come back here. It's almost done. We're going to throw an f of x equals in front of it. And now we have our function in vertex form. So what is our vertex? Okay, our vertex, we're going to make two sets of parentheses. Remember, even though there's a negative on the outside, this negative's job is just to tell me that this is reflected, that my arrows are going to go down. We still just look at what's inside the parentheses. We take the opposite of that value, so positive 3, and we keep that number on the outside of the parentheses exactly the same. So the vertex is positive 3, positive 4. Okay, on number 4, we are in standard form. We have f of x equals 2x squared minus 12x plus 13. I want to change this to vertex form. So I'm going to start by making a grouping out of my x squared term, so 2x squared minus 12x. That's the a and the b terms here. We put them in parentheses and we kick our constant on the outside. And then I'm checking, what's my a value? Oh, well, a is equal to 2. Right there, that guy. We can't have an a value that's not 1. So if we had something larger than 1, we have to factor it out. So we're going to take that 2, we're going to put it on the outside of the parentheses, which means we're dividing 2x squared and negative 12x by that 2. That's how we pull it out. We divide it out. So we're left with x squared minus 6x inside the parentheses plus 13 on the outside of the parentheses. So now we're on to our step where we take our b value. Again, that's going to be negative 6. We're going to take half of it, so divide it by 2, and we get negative 3. And we're going to wrap parentheses around it and square it, which means negative 3 times negative 3, which is positive 9. Okay, this number, again, we use it in 2 places. I'm going to rebuild what I had above. I have 2, and then I have x squared minus 6x in parentheses, but I'm going to say plus my box, close the parentheses, and then I had the plus 13 already on the outside, and I'm going to say minus the box. And this box, again, is my a times c value. Okay, the a is the number on the outside of the parentheses, c is the number that goes in the box originally, okay, in our first box, that new number. So what's going in the first box is our number 9. Again, I'm drawing, it's got 2 arrows to it. So 9 is the new c. What goes in the second box on the outside is a times c. So 2 times 9 is 18. So that's what we're putting in there, a times c. So now we're going to go back and we're going to factor what's in the parentheses. It's a perfect square trinomial now, so it's like way easier. What multiplies to positive 9 but adds to negative 6? Again, it's going to be half the b value. Negative 3, negative 3. Look there if you're stuck. So we're going to write this as 2 and then parentheses x minus 3. There's 2 of these negative 3, so we're going to say this is all squared. And then what goes outside of that? Well, 13 minus 18 is negative 5. Okay, our function's almost complete. We just have to throw the f of x equals in front of it, and we're done. From here, we get the vertex. So our vertex, v for vertex. Okay, we have in our parentheses the opposite of what's inside with x, so positive 3, and the y value that's on the outside is negative 5. It stays the same. Now, what was the job of the 2 on the outside? The job of the 2 that we factored out. We don't have to put this, but remember that's going to be a vertical stretch of 2. He made this a skinnier parabola. Okay. Okay, number 5, our function in standard form is f of x equals x squared minus 3x minus 2. So we're going to rewrite this in vertex form by completing the square. So we start by making a grouping of our x squared minus 3x, and we kick the constant out to the outside. I check my a value is equal to 1, so we get to leave that alone. We don't have to factor anything out. We're now going to take our b value, which is negative 3, and we're going to divide it by 2. And now I'm going to pause for a minute. I have negative 3 over 2. This does not divide evenly. So on our first 4 examples, we always had an even b value, and we know that all even numbers divide evenly by 2. And so we haven't had to deal with any fractions. Well, we don't always have even numbers that we get to have in our equations. So we can still do this. This just means we're dealing with fractions, which is okay. You know, even if you hate fractions, remember your calculator doesn't hate them. Okay, it doesn't discriminate. So we're going to keep going from here. We'll just leave it as an improper fraction. So negative 3 over 2 is going to stay that way, and then we're going to square it. So that means negative 3 over 2 times negative 3 over 2, which is equal to positive 9 over 4. And again, that's still our new c, even though it's a fraction. We don't hate him. We're going to keep working like we have. We were going to take what was inside the parentheses and rewrite this as x squared minus 3x, and I'm going to say plus my box, which again, that's the new c. I had a minus 2 on the outside, and I'm going to say minus my box, which was a times c. Now, it will be the same here because I don't have an a value other than 1. So we are going to have, let's see, 9/4 here and 9/4 here. Okay, now you might be thinking at this point, well, we might be thinking Miss Orson's crazy, but factoring this is no more difficult than it was before. What multiplies to 9/4 but adds to negative 3? Well, guess what? It's still going to be what half the b value was, negative 3 over 2. We still have that clue from above. Negative 3 over 2 times negative 3 over 2, that does multiply to positive 9/4. If you checked in your calculator, when we put negative 3/2 minus 3/2, we would get negative 3. So we check out both ways. So the fractions didn't really mess us up because we still get to use that shortcut. We're going to rewrite this now as x minus 3/2 all being squared, and then we simplify the outside, -2 and -9/4. We will keep writing it as an improper fraction. We're going to say minus 17/4. And this is done after we put our f of x equals in front of it. So here's our function. What is our vertex? Okay, that doesn't change either just because we're dealing with fractions. We will have a positive 3/2 for our x value and a negative 17/4 for our y value. Now this doesn't mean it'd be fun to graph, but it is correct, okay, because we did all of our steps right and not every parabola is going to work out to whole numbers. Okay, number 6, we have f of x equals negative x squared minus 9x minus 22. So let's complete the square. We are going to start by making a grouping out of the first two terms, negative x squared minus 9x. We're kicking out negative 22. And then I've noticed that we've got a negative sign. A is -1. That's a no-no. So we have to pull that negative outside the parentheses, and in doing so, we're dividing each of these terms inside the parentheses. So we're going to end up getting a positive x squared and a positive 9x. Okay, when we divide by -1, we just change signs. Now let's bring down our negative 22 on the outside. From there, we're going to take our b value, which is 9. Remember, b is the number in front of x. We're going to divide b by 2. 9 is odd, so it doesn't divide evenly by 2, so we're going to leave it as 9/2. And we're going to square that. So really I'm thinking 9 squared is 81 and 2 squared is 4. So we get 81/4, and this is our new c value. So we're going to bring down, okay, what we had above that and rewrite this as negative, and then x squared plus 9x, and I'm going to say plus my box, close it up, bring down that minus 22 we have, and I'm going to say minus the box. So remember, we add inside the box, inside the parentheses, and we add or subtract it outside the parentheses, excuse me. I have weird things popping up on my screen. I don't know if you can see that. So what goes inside here, that's just our new c value. We're going to put in 81/4. What goes outside, in the outside box, is a times c. So we are going to, this is a is -1 and c is 81/4. So we get a negative 81/4. So we've got this double negative thing happening here. Okay, it doesn't really slow us up too much. We're going to factor what's inside the parentheses. What multiplies to positive 81/4? And equals positive 9. Okay, again, don't be tripped up. It's always half the b value. So it's going to be 9/2 and 9/2. They're both positive. 9/2 times 9/2 is 81/4. 9/2 plus 9/2 is equal to 9. So we're going to rewrite this now. We had the negative on the outside. We're going to bring it down. Then parentheses, x plus 9/2 all being squared. And then what is negative 22 minus negative 81/4? So remember, that would become plus, and we should have negative 7/4 here on the outside. So we're going to throw f of x equals in front of all this, and we are now in vertex form. What is our vertex after all of this business? Okay, our vertex is going to be negative 9/2 for x, negative 7/4 for y. And it's done. Okay, number 7, we have the function f of x equals x squared plus 5x. Notice we don't have a constant. It's like saying plus 0 over here. So you could write that in if you want, but you don't have to. So we're going to start the same way. We're making a grouping out of our first two terms, x squared plus 5x. Okay, and technically we guess we have that plus 0 on the outside. We're going to check our a value is equal to 1 here, so we don't need to take anything out. We don't have to factor anything out as a GCF. So we are going to then take our b term. The b term is 5. So 5, we're going to take half of it, which means divided by 2. It doesn't divide evenly, so we leave it as a fraction, and then we square it. 5 squared is 25. 2 squared is 4. And this is the new c. So we're going to take what was in parentheses above, that grouping, and we're going to rewrite this. We had x squared plus 5x, but we need to add something inside the parentheses, so I'm making a box to represent that. I had 0 on the outside, so I guess you could put plus 0 and then minus your box. Okay, this would be a times c, but remember if our a value is 1, it really is just c. So what's going in the box is our new c. We're putting in 25 over 4 here and here. So now we factor what was in the parentheses. What multiplies to 25 over 4 but adds to 5? Well, it's going to be half of b. 5 halves times 5 halves equals 25 over 4, and 5 halves plus 5 halves does equal 5. Okay, so what do? Now we're rewriting this in factored form. We would have x plus 5 halves. We had 2 5 halves, so we could say all this is squared. And what is 0 minus 25 over 4? Well, it's going to stay negative 25 over 4. Okay, so we just come back and we put f of x equals in front of it, and we have our function. We can write our vertex from this. Our vertex is an ordered pair that we are symmetrical about. We take the opposite of what's inside the parentheses, so we have negative 5 halves, and keep the other value the same. So our vertex is at negative 5 halves and negative 25 fourths. Okay, moving on to number 8. Okay, we have f of x equals 4x squared minus 8x. Again, we do not have a c value, so I'm going to make a grouping of my 4x squared minus 8x. Okay, we could technically say that's plus 0 on the outside. I do notice that my a value is greater than 1. A is 4. So we need to pull 4 outside the parentheses, meaning we're dividing it out of each of these two terms. 4x squared divided by 4 is just x squared. Negative 8x divided by 4 is negative 2x. And we have that plus 0 on the outside. Okay, now we're going to take our new b value here, which is here, negative 2, and divide it by 2 to get negative 1. Okay, that did divide evenly, and now we square it. Negative 1 times negative 1 is positive 1. So that's our new c. We are going to bring down what we had in parentheses above that and rewrite it as 4 parentheses x squared minus 2x. And I'm going to say plus my box, which represents my new c value. And then I had my plus 0, and I'm going to say minus this box, which represents a times c. Okay, what goes in for c? Well, the new c was 1. So it goes here, but 1 times, we have a times c that goes here. So a was 4. 1 times 4 is 4, is going in the outer box. So now we're factoring. We're asking what multiplies to positive 1 but adds to negative 2. It's still that half of b value, negative 1 and negative 1. So now we're ready to write this in vertex form. We have 4 parentheses x minus 1, all being squared. And then on the outside, 0 minus 4 makes negative 4. So we have f of x equals 4 times x minus 1 squared minus 4. What is our vertex? Our vertex, okay, just comes from taking what's opposite of inside the parentheses with x, making it positive 1. The y value is the outside value. It stays the same. So our vertex is 1, negative 4. What did this 4 in the front do? Again, that's 4 is larger than the absolute value of 1, or okay, just larger than 1. So we have a vertical stretch. This means we got a really skinny parabola here. Vertical stretch of 4. The higher the number, the skinnier the parabola. Okay, number 9, we have f of x equals negative 2x squared plus 20x minus 46. So starting this process all over again, we're making a grouping of the first two terms. We have negative 2x squared plus 20x, and then kick out minus 46 to the outside. Here my a value is negative 2. It's not positive 1, so we have to pull it out. So we're pulling negative 2 to outside of parentheses, meaning I'm dividing each of these two terms by negative 2. We get positive x squared, and 20 divided by negative 2 is negative 10x. And then we put minus 46. It just gets brought down. We haven't used it yet. Okay, so now that we've done that, our b value is now negative 10. So we're going to take that negative 10, take half of it, so we have negative 5, wrap it up in parentheses and square it so that we get positive 25. That's our new c. So I'm going to take this blue part from above, and I'm going to rewrite it. We have negative 2 parentheses x squared minus 10x, and I'm going to say plus my box, which is c. I had a negative 46 on the outside, and now I'm going to say minus the box, which is A times C. What's going in the box? The first box, it's the new C. Okay, so 25 is going in this box, but what goes out here is negative 2 times 25, which is negative 50. So notice we have a double negative situation out there. So let's factor what's inside the parentheses. That's our next step. What multiplies to positive 25 but adds to negative 10. Again, half of B if we haven't figured that out by now. So negative 5 and negative 5. So rewriting this, we have the negative 2 outside the parentheses. We have basically 2 negative 5, so x minus 5 squared. And then here on the outside, we have negative 46 minus negative 50, which really means negative 46 plus 50, which is positive 4. Okay, no fractions on that one. We have f of x equals negative 2 times x minus 5 all being squared plus 4. That's vertex form. What is that vertex? Our x value will be positive 5, our y value 4. Okay, this negative 2 out here, the negative tells me my arrows will end up going down. 2 means it's slightly skinnier than usual, a vertical stretch. Okay, number 10. We have f of x equals negative 1/2 x squared minus 4x minus 5. Okay, so I have a fraction for my a value. That hasn't happened yet. But we still are going to make a grouping out of our first two terms. Negative 1/2 x squared minus 4x is in the parentheses. We kick out negative 5. My a value is negative 1/2. Again, whatever that a value is, we have to pull it to the outside of the parentheses. That means we're dividing it out. So I'm going to take out negative 1/2. Now, that means that my a value, what's inside the x squared, is just x squared. Okay, we pulled out that negative 1/2. What is negative 4 divided by negative 1/2? Okay, that equals positive 8, I believe. Yes, it does. So it equals 8. So now we have plus 8x. When you divide by a fraction, remember you're really multiplying by the reciprocal. That's why it got larger here. So plus 8x and then minus 5 on the outside. So now we're ready to take half of our b value. So we take 8 and divide it by 2, which is 4. Wrap it in parentheses and square it to get positive 16. Hey, that's our new c. Cool. Okay, let's bring down what we had above. We have negative 1/2 on the outside, then x squared plus 8x, and I'm going to say plus my box, which is the new c. Close that parentheses. I had a negative 5 on the outside, and I'm going to say minus the box, which is a times c on the outside. And how do I know this? Because it's the rules, and we just follow the rules here because we like to do that. So our c value, what's going inside is 16. What's going in this outside box is a times c. So a is negative 1/2, so negative 1/2 times 16 is negative 8. So we're putting negative 8 in this box. So now we factor. So what multiplies to positive 16 and adds to positive 8? It would be 4 times 4. 2 positive 4s. So when we factor this, we have negative 1/2, parentheses, x plus 4 squared, and then my outside, it's negative 5 minus negative 8. My double negative turns positive, so negative 5 plus 8 is positive 3. So throw f of x in front of this sucker, and that's our equation in vertex form. What is the vertex? Okay, our vertex is negative 4, positive 3. So bonus question, what does this negative 1/2 do? The negative means that it's opening down, and then the 1/2, because that value is less than 1, it means that it's slightly, like we have a vertical compression, got a little fatter, okay? So it got a wider bottom, and that's it. Okay, looking at number 11, we're going to put all this together. We're going to convert this from standard form to vertex form and then graph it as well. So working through all of our steps, first we make a grouping of our first two terms. So we have x squared minus 12x in the parentheses. We're kicking out positive 39. Our a value is 1, so we are good to move on from here. Our b value is negative 12. We're going to divide it by 2, and we get negative 6. Wrap it in parentheses and square it. Negative 6 times negative 6 is positive 36. Hey, that's our new c. So we take what was above and we're going to rewrite it. We have x squared minus 12x plus my box, which is my new c, close the parentheses. We're going to bring down our positive 39 and say minus our box, which is a times c. What's going in the box? C value was 36. Since our a value was 1, 36 times 1 stays 36. Again, that's why it stays the same sometimes. So now we're factoring what multiplies to positive 36 and adds to negative 12. Well, that's going to be negative 6 times negative 6. Again, that's half of the b value. So we have x minus 6. Again, remember, because there's two negative 6 here, we can say all this is being squared. And then on the outside, we have 39 minus 36, which is positive 3. So our function here in vertex form is x minus 6 squared plus 3. So what's our vertex? Well, and again, that vertex will go in the middle of the table here, is positive 6, positive 3. So here's my origin. I'm going to go right 1, 2, 3, 4, 5, 6, 1, 2, 3, up. Now I also know, because my a value is positive, I don't have a negative out here, that my arrows should be going up on either side. So if we fill in the rest of the table, to the left of 6 we have 5, 4, and 3, 7, 8, and 9. Okay, if we plug in 3, we get 3 minus 6, all being squared, plus 3. What does that equal? And that equals 12. Okay, we plug in 4, we have 4 minus 6, all being squared, plus 3. Okay, we get 4 plus 3 is 7. We plug in 5, we have 5 minus 6, all being squared, plus 3, and that's going to be 4. And remember, all parabolas are symmetrical, so our points are going to repeat on either side of the vertex. So we'll have 4, 7, and 12. So on either side of our vertex, we're going up to 4. And then on either side of that, we're up to 7. And we can't plot 12. So we're just going to connect our points. And here we go. Okay. So much easier when we're already in vertex form. And that's it. Have a great time completing the square.